Welcome to Web Handling. My name is Dave Roysam. In this clip, we will outline the causes and cures for the rare crepe wrinkles and related winding defects. As we will see, they are caused by non-uniform interlayer slippage induced by rolling nip, such as a wound roll against a layon roller or a drum. I know your time is precious, so let's get started. The crepe wrinkle is just one of a family of rare winding defects that have similar mechanics. The others in this family include bursts, core bursts, cigars, and possibly corrugations. These defects are quite rare for two reasons. First, they only manifest on a very few paper grades. While it might be possible for non-paper materials, I'm not aware of it, at least at this time. Second, even in paper, it is confined to only a few subset grades such as magazine, newspaper, and tissue, and then only on a few subspecies of that subset. To make matters worse, the defect has an extremely complicated mechanics. Back in the 1980s, at the height of the AIDS epidemic, I wrote a definitive paper on this subject. I coined the acronym NIDS, which is short for Nip-Induced Defect Syndrome, to capture the essentials of the mechanics. So, why would I bother with a discussion of a rare and complicated disease? Simple, because for some, this is an economically devastating disease. So, how do you know if you have this rare disease? Simple. A picture is worth 1,000 words, and these three pictures are classic presentations of three different variants of the NIDS disease. In the next couple of slides, I will only give a very brief overview of the mechanics of defect generation because a full discussion would take an hour or two. The mechanics of this defect is most easily seen using the J-line technique, which should be known by people familiar with winding, especially for soft products such as paper, fiberglass, nonwovens, textiles, tissue, as well as for troubleshooting telescoping. In any case, layers can slide under the nip, whether the nip is a drum or a layon roller. If you look on a micro-layer view, you can see the top layer of the wound roll slides the most as the nip passes. So, as the wound roll layers build, the layers an inch or two under the current top of the wound roll will eventually freeze into their new and final locations. However, if the slippage were uniform, we would not have any of the NIDS defects, including corrugations. A final ingredient is that the slippage must be non-uniform with respect to either radial or cross-direction position. These motions can be extremely complicated, something like the movement of tectonic plates during earthquakes. If the slippage occurs more on one layer than its neighbors above or below, and occurs in the MD, then the paper can tear or crepe depending on whether the movement is tensile or compressive. The movement can also be non-uniform with respect to CD position, which results in shear stresses. The figures at the right shows that all three of these non-uniformities of motion, tension, compression, and shear can happen in the same area, resulting in the classic core burst that plagues newspaper, magazine, and other materials. So, rather than taking an even deeper dive into the mechanics, which could take the better part of an hour, let us instead focus on the winders and the locations on the winders where we see nips that are known to cause crepe-like defects. These include the bottom of the parent rolls due to their weight. These include all three and possibly a fourth nip on two drum winders. These risky nips include at least one and possibly three nips on duplex winders and one or two nips on unwinds. The reader who is not familiar with winding may be quite surprised by me labeling nips at the bottom of a wound roll. However, those familiar with mechanics will know that the Hertzian contact stresses are identical for a core bearing the weight of a roll on the inside as they are on the outside due to a drum or layon roller. Another learning and complication is that cores and spools bend, meaning that the stresses will be higher on the ends, meaning the slippage and defect may be only seen or clearly favor the AZ or outside rolls. Risky situations are foreseeable, but not predictable. This defect is as complicated as trying to predict earthquakes. Knowing where an earthquake might happen is easy. Knowing when is impossible with current understandings. Since we know well the risk factors, we can also generate a pretty complete list of treatments. However, like diseases of the body, it is almost impossible to predict the efficacy of a given treatment for a given situation. Much of our knowledge of this defect family resulted from uncountable observations in plants. Here is a list of the ways that you might be forewarned about this hidden defect. I know this discussion has been rushed to keep this clip to a reasonable length. I could easily go on for another hour. For those who have this defect and want to know more, just email me at drroysum@aol.com and I will give you 2 papers I've written that go into much more depth. Thank you so very much for joining me in this defect solving and defect preventing series. Stay tuned for the next week's show where we will talk about another rare but troublesome defect, the slip pimple. If you have a defect you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.